Let two lines L and M and the plane P be given by. Question A. Find the coordinates of the point of intersection of line and plane. But first of all, let's rewrite our lines in vector or parametric form. So how to do that? Since equals and equals some constant, let it be lambda, and hence just solve for x. X is what? 3 plus 2 lambda, and y is what? -1. Y is -1 plus 4 lambda, and z is what? 2 minus lambda. It's a parametric form, and it becomes this vector plus lambda and multiplied by this vector. And for M, it's for L, and for M, it becomes x, y, z, and let it be mu. So for x, it's 6 minus 4 mu, 6 minus 4 mu. For y, it's just 2 mu, and for z, it's just -10 plus mu. And we need point of intersection of the line L and plane. How to do that? We just substitute x, y, z into Cartesian equation of the plane and solve for this unknown parameter lambda, and then if you know lambda, you can find the required point, and we can do it here. So it becomes x, 3 plus 2 lambda, plus 3y minus 3 plus 12 lambda, minus 2z, so -4 plus 2 lambda is 4. Let's check x, 3 plus 2 lambda, plus 3 minus and minus 2 minus 4 plus 2 lambda is 4. Okay, and you can see 3 cancels, and it becomes what? 16 lambda is 8, so lambda is a half, hence point becomes 3 plus 2 times a half, so it's 4. Y -1 plus 2, it's 1, and 2 minus a half, it's 1.5. The next, calculate the acute angle between L and a plane. So this situation looks like this. There is a plane and the line, and we know that a line has a direction vector, and this direction vector, and what line should be considered? Acute angle L, it's line L, and it's our plane P, and direction vector of L is this 2, 4, -1, and in general we can take any multiple of this, so 2, 4, -1, 2, 4, -1, and plane has normal, and normal is just these coefficients 1, 3, -2, 1, 3, -2, and we need this angle alpha. But since we know two vectors, we can apply what? Dot product to find the angle between two vectors. in general it may be maybe in this direction. If I would find, for example, 150, I understand that when two lines intersect there are two angles which add up to 180. So if I would calculate 180, I just say that acute becomes 30. So we can find theta firstly, and then the required alpha will be 90 minus theta. So it's theta. So dot product, yes, and we can see the n and b. Dot product, it's x by x, it's 2 plus y times y 12 plus 2, so it's what, it's 16, and magnitude of n, it's what, root of 1 plus 9 plus 4, it's what, root of 14, and magnitude of b is what, root of 4 plus 16 plus 1, it's root of 21. And on the other hand, this dot product is magnitude of one vector times magnitude of another times cosine of the angle between them, and hence cosine of theta is 16 over root of 14 over root of 21, and you can see that cosine is positive, so theta, it will be acute. If you get cosine to be negative, it means that cosine is greater than 90, then acute is just 180 minus this obtuse angle. Because as direction we can take any multiple, and also we can take in opposite direction, so two possible angles between two vectors, and also n may be taken in this direction or something like that. So just using a calculator, 16 divided by square root of 14 multiplied by 21, and then inverse cosine of the answer, and it's in degrees, it may be in radians, it doesn't matter, 21.1, so theta is 21.1 degrees to three significant figures, and we need actually alpha, and alpha is 90 minus our answer, and it's required, it's actually what, 68.9, so alpha is 68.9 to three significant figures, and it's the required angle between the line and the plane. The next C shows that line M is parallel to the plane P. So the situation looks like this: line, now it's M, and line has direction vector, and plane has normal, and you can see that if line is parallel to the plane, normal becomes perpendicular, and to show that it's true, if we show that normal dot product direction vector is 0, it implies that normal is perpendicular to the direction vector of the line, and hence line is parallel to the plane as required. So we should consider dot product of n, and it's the same 1, 3, negative 2, and direction vector of M, it's negative 4 to 1, negative 4 to 1. and dot product is 1 times -4, it's -4 plus 6 minus 2, and you can see it's 0. Hence n is perpendicular to b, and hence line is parallel to the plane as required. D shows that lines L and M do not meet. It means do not intersect. And direction vector of line L is this 2, 4, -1, 2, 4, -1, and direction vector of line M is -4, 2, 1, and we can see that coordinates are not proportional. I mean that two vectors to be parallel, it must be like this: 2, 3, 20, 30, and we can write that here one direction vector is not constant multiplied by another direction vectors. It implies that lines are not parallel. Lines are not parallel. And because they can not meet if they are parallel but not on the same line, but here they are not parallel, so we shouldn't consider this variant at all. And now let's just try to find a point of intersection. How to do that? And actually, let's write here, it will be more suitable. We just equate x to x, y to y, z to z. So we write that 3 plus 2 lambda is 6 minus 4 mu. -1 plus 4 lambda is 2 mu, and 2 minus 2 2 minus lambda is -10 plus mu. Then we choose any two equations and we need to solve for lambda and mu, and actually we can choose the second and the third, and by elimination let's multiply the third by -2, -2, so -4 plus 4 lambda, we multiply by -2, so -4 plus 2 lambda. -2, -4 plus 2 lambda is plus 20 minus 2 mu, and now add both sides to get -5 plus 6 lambda is 20, and hence 6 lambda is 25, lambda is 25 over 6, 25 over 6, and for example from the third, mu is what 12 minus lambda, 12 minus lambda, and it becomes 12 minus 25 over 6, and it's what over 6, and it's what 72 minus 25, it's what 50, 47 over 6, and then we substitute these values for lambda and for mu into the remaining third equation, and if you get that this third is true, hence there is a point of intersection, and you just substitute lambda or mu into this or this, it doesn't matter, and hence you can find the point. But if I get that it's not true, hence lines are skew. It means that they are not parallel and they don't intersect. And it becomes 3, let's write like this, left hand side is 3 plus 2 lambda it becomes 3 plus 50 over 6, and the right hand side it's 6 minus 4 mu, and it's 6 minus 4 times 47 over 6, and it becomes 4 times 47 and minus 36, and it's negative 152 over 6, and it's what, 668, and we can see that the left hand side is not equal to the right hand side, hence lines are not parallel, and definitely they don't meet or intersect, and it's called they are skew lines. And if we know that they are skew, and if I make a mistake, I will not see it. Okay, and do not meet, and E, calculate the shortest distance between lines. The shortest distance between lines. So this situation looks like this. There are two lines, L and M, which are the skew lines, and the shortest distance, it's distance which or line segment which will be perpendicular to both lines. And there are two methods how to find this shortest distance, and let's write here. The first method is I need some vector in this direction on this line which is perpendicular to both lines. Or actually, let's find the vector which is perpendicular to both lines, and we know that we know direction vectors for both lines, and a vector which is perpendicular to b1 and b2, it's what, it's a vector which can be obtained as what, as a cross product. So this vector in this direction, let it be vector, I don't know, A, or let it be n, and it's a vector which can be obtained as cross product of b1 and b2. Length doesn't matter, and you may use a formula from a data booklet. I use another formula. It's a determinant of the next matrix ijk. b1 it's 2 4 negative 1, and b2 is negative 4, 2, 1, negative 4, 2, 1, and then it becomes plus I, and determinant of these 2 by 2 matrix, it's what? 4 minus this product minus this product, so it's 4 minus negative 2, it's 6. It's 6 minus j, and 2 times 1, 2, 2 minus 4, it's negative 2. It's negative 2 or plus 2, and plus k, and this determinant, it's 4 plus 4 minus negative 16, it's 20. It's 20. And length of this vector doesn't matter. I can take any multiple, and as a multiple I can take this vector to be 3, 1, 10. 3, 1, 10. And then I choose absolutely any 2 points without any parameters on these lines. And as a point, you can see that these values are points. So vector AB becomes vector. It's can be found as coordinates of a vector, can be found as coordinates of the endpoint minus the coordinates of the starting point, so coordinates of B, and it doesn't matter BA, AB, so it becomes 6, 0, negative 10, 6, 0, negative 10, minus 3 plus 1 minus 2, and it becomes what? 3, 1, negative 12. And then there is a vector in this direction, in direction of the line which is perpendicular to both lines, and then to find the shortest distance we need just find a projection of this vector AB onto this vector n, parallel projection on n, and parallel projection, it becomes, and it will be actually the required distance, it becomes dot product, it's a b vector dot product n magnitude and divided by magnitude or length of n, and that's why length of n doesn't matter, and it becomes AB dot product with n, so 3 times 3 is 9, plus 1 plus negative 120, so it's what? It's actually it's 10, so it's negative 110, and magnitude, and the magnitude of n, it's what? Root of 9 plus 1 plus 100, so it's a root of 110, so finally it's a root of 110. Another method, we again we need a vector in direction of the line which is perpendicular to both lines, which can be found like this, like a cross product of two direction vectors, and then we consider two position vectors to any points on both lines, so we can see the OA vector and OB vector, and we should take with parameters, so we consider so it becomes OB vector. It will have this coordinate 3 plus 2 lambda, -1 plus 4 lambda, and 2 minus lambda, and position vector of OA, it becomes just this, 6 minus 4 mu, 2 mu, -10 plus mu. And then we consider again vector AB or BA, but in terms of parameters. So parameters will be what? For the previous method, we consider just 2 points, 2 specific points with coordinates, and then we have no parameters. Here we consider with parameters in general, so it's any point on the first line, any point on the second line, and in general it's in general vector between any 2 points on both lines, and hence this vector AB becomes just difference. So 6 minus 4 mu 6 minus 4 mu 6 minus 4 mu 2 mu 2 mu and -10 plus mu minus minus minus, and this 3 plus 2 mu, so minus 3 minus 2 mu lambda minus 3, then minus or plus 1 minus 4 plus 1 minus 4 lambda plus 1 minus, and minus 2 plus lambda minus 2 plus lambda. And let's simplify, so it becomes what? 3 minus 4 mu minus 2 lambda, 1 plus 2 mu minus 4 lambda, and what? -12 plus mu plus lambda. And idea is the next. This arbitrary chosen vector between 2 points, to be the shortest distance, this vector AB must be parallel to this vector through the line which is perpendicular to both lines, and the vector, when we know that 2 vectors are parallel, they look like 2, 3, 20, 30, and on one hand we can say that one vector is constant multiplied by another vector, or also we can see that coordinates are proportional. We can do proportion like this, or we can write proportion like 2 over 20, the same as 3 over 30, and our n vector is 3, 1, 10, and n vector is 3, 1, 10, and coordinates are proportional, or this vector is some constant multiplied by this vector, and or to be the shortest distance, this vector must be parallel to this vector. And we can make the next proportion or proportions and try to solve. And if you know mu and lambda, you know the required vector AB, which will be the shortest distance, and hence we will find the length of AB, and we should get the same 110, root of 110. So we can write the next, that 3 minus 4 mu minus 2 lambda over 3 should be equal to x over x, y over y. So 1 plus 2 mu minus 4 lambda over 1. And you can see that since there are 2 unknown variables, we need another equation. So let's consider y over y and z over z. So 1 plus 2 mu minus 4 lambda over 1 is equal to negative 12 plus mu plus lambda over 10. And 3 minus 4 mu minus 2 lambda is 3 plus 6 mu minus 12 lambda. And the second becomes what? 10 plus 20 mu minus 40 lambda is negative 12 plus mu plus lambda. So let's simplify. 3 cancels and we get 10 mu is equal to 10 lambda, so mu is lambda. And for the second, 10 plus 20 mu minus 40 mu, since lambda is mu, and minus 12 plus mu plus mu. So it becomes negative 20 and plus 2, so 22 mu, 10 plus, so it's 22, so mu is 1 and lambda is also 1. Hence our AB vector becomes 3 minus 4 minus 2, 1 plus 2 minus 4, and negative 12 plus 1 plus 1. And it becomes what? 1 minus 4, negative 3, negative 1, and negative 10. And hence AB magnitude becomes a root of 9 plus 1 plus 100 and a root of 110. And we can see that we get the same result. And that's all for this question.